Recording now. So hi, first of all, to everyone who has joined. We're very happy to see you here. Hopefully a few more people will join during this workshop. But this is our third workshop. So I'm talking on behalf of the Economics and Business Society, and we're doing these workshops together with the Student Developer Student Club. I'm sorry, I always mix that up. But yeah, this is the third one. We will have a quick recap from the last two sessions in the beginning. So if you haven't joined or if you didn't join those workshops, no worries at all. Like Darius and Eric will do a quick recap, so it should all be fine, and so that you remember what we actually did the last couple of times. As you can see, and as you probably read in the Facebook description, this workshop will be a bit different as we are advancing to new topics. So Darius and Eric will be talking about Python with pandas for data manipulation. I'm not an expert, so I'm not going to talk about this too much. I think that we can go ahead and start, and you guys can make the recap and start with the content. So thank you once again for everyone who has joined.
Yes, so thank you, Amanda. Hi, everyone. I'm Darius, and I'm here with my friend Eric. We're part of the Developer Students Club, University of Aberdeen, and we're gonna now deliver the workshop. This is the third workshop, and we're gonna have one more next week, and yeah, we're gonna be done. So just as an agenda, we're gonna talk in this session about. First, we're gonna have a quick recap from the last 2 weeks. And then we're going to answer questions like, what is data analysis? Why Python? Why would you use Python for data analysis? And lastly, we're going to talk about pandas and basically about data frames in Python. So as a quick recap from the first workshop, remember that we talked about basically functions and how to define a function. As an example here, we have the function findMax, and it's having the parameter called numbers. And don't forget to put a colon every time you define a function. And then what this function does is basically manipulating over a list and giving the maximum number from that list. So basically here, okay, we assume that the given list only contains natural numbers, and we defined this variable called max number, which is going to be 0 at first. And then we're going to iterate to the list by using the for command, and each time if we're going to find a number bigger than the max number, we're going to change the max number to that number. And in the end, max number would store the maximum number from that list, and we're going to return it by using this command. So we're going to do this. We're going to apply the findMax function to this list from here. If you run the command, it's going to print 9 because 9 is the biggest number from that list. And in the second workshop, we talked about more things, more advanced stuff. Firstly, we talked about libraries, and we can see here how to import the library. Here we imported the library random, and if you just hover over it, you can see like some things about that library. And we basically worked on files. So this is how you open a file with this command. Just write the command open, and here you parse the file name and then the read mode.
Mm-hmm.
And this command called w+ would be basically means that we're gonna read the file and we're gonna write it at the same time, and it's gonna create a new file if the file doesn't exist. After that, we can even open a file in the append mode, which means that we can add several things to the file. For example, here we're adding these lines to the newly created file that we had. And don't forget after each of these commands to close the file with f.close. You can even just read the file with the R mode. And here we created the content variable. And with this command f.readLines, we're going to basically create a list with all of the lines from the file. And after that, we can use this command. We can iterate all of the lines and the content and just print the line. And we also delve into this lucky line thing, which means that we're gonna we're gonna show the screen which is the lucky line by using this command random.rand int from 0 to len content of -1, and it's gonna give us a random number from that range. We also learned how to define dictionaries, and here is the best example with the book. When we're gonna have a title, and then to the title key we're gonna have a string, same for the author. For the length we're gonna have a number, an integer, and for the text we're gonna have a list. And here's how we're gonna add things to the dictionary with book.update, and we're gonna specify the key and then the value. We can do it even easier by using this command, and this can apply for every line from here. And lastly, we can even create another file which is gonna be our book by using this command. So basically, we're gonna use the title as the name of the file, which is gonna be this one. And after that, we're gonna write everything that we have in the file. We're gonna write the number of lines and the length of the book and the author. And let me run all of this now. And yeah, basically this is gonna be our output. And I'm gonna show it better to you from the files. So basically, when we create a book text file, we're gonna add these things to the file. Okay, this command print.fread is gonna print the file at first, but the file is empty at first, so it's not gonna print anything. And after that, as we add all of these things to the file, this line is gonna be executed here, and we're gonna print these 4 lines. And this is how the book.txt file is gonna look first. And after that, while creating the book, here's what it's gonna contain. So basically, we have all of the text that we added before. Then we add it here to the variable content. And then we're gonna have the number of lines, which is specified here, and the author, which is specified here. Okay, that's all about the last 2 workshops. Hope I didn't talk about this too long. Okay, so now, what is data analysis basically? Like, we've been told all these things for this whole week that we're gonna talk about this subject. And basically, this is the process of inspecting, cleansing, transforming, and modeling data. What do those things mean? Well, basically, we're gonna gather some data, and first we're gonna clean it. Like, we might have some empty rows in the data, and we have to manage them properly. We're gonna transform the data in whatever way we want. And last but not least, we're gonna model the data. And what does this mean is basically updating real-life scenarios to some information systems. And after that, we can even perform some statistical analysis on that data. And the main 2 goals of this are discovering useful information and driving interesting conclusions from the data. This subject is very important because it basically covers, and it can basically be used in many fields like marketing, sales, accounting, even in medicine probably. And yeah, we're gonna do all of these actions by using Python. Why would you use Python for data analysis? Well, it's a very simple and intuitive programming language to learn. We saw this in the last 2 workshops. And it's got these very powerful libraries like pandas, which you're going to explore for this workshop, and also matplotlib and seedborn, which we're going to see in the next one. Python is also free and an open source, which means that anyone can have access to it, and it's got like very good forums, and you can ask questions and they're going to reply to you within some hours or even days. And also, it's much easier to maintain than other programming languages. You might have used R before. It's widely used in university. Even like at our university, it's used in the understanding data course for first years, and even in one of our computing courses. But the problem with R is that it's like kind of tedious to write. For example, this is a code in Python that computes the mean of some data, and this is the same code in R. So you can see how tedious R is sometimes when we want to compute some basic things like a mean. You can write 3 lines of code in Python; they're very easy to understand. Whereas in R, you have to write much more, and there are more complicated things here. And as I just mentioned, we're gonna use the pandas library. So firstly, we're gonna import the pandas library here, and we're gonna add an alias to it called PD. So every function we're gonna use from the pandas library we're gonna use it by with the PD alias. So firstly, I have to run this cell because how Jupyter Notebook
I think you're muted just now, like just a few seconds back.
Sorry, was I muted for a whole thing?
No, not for long. Just a few seconds. No worries.
Like,
Like,
I don't know what happened. So basically from here. Okay, as I just said, we're gonna import the pandas library, and we're gonna add an alias to it, and we're gonna run this cell, and this is how we're gonna work with every function from the pandas library. And we're gonna work with data frames, which are basically two-dimensional labeled data structures with columns, and the columns can have basically any type. And they're mostly used for manipulating tabular data, like some databases, some CSV files, and even like some web data. And the best thing to think about data frames, the best way to think about data frames is as a dictionary. And as a note, it's very tedious to create a data frame manually. This is an example, let's say, and we're gonna use the df alias, which would stand for data frame. And here from the PD library, we're gonna use the data frame command. And this is how a data frame would look like, basically like a dictionary, which is gonna be defined between these brackets here. And we can have like, let's say we're gonna work on a database with movies, and let's say we have the name of the movie, and here we're gonna have 5 names and the runtime of each movie, the rating, the year, and the director of each movie. And now, if you're gonna run all of this, here I mentioned df. You can even write print df is the same thing. It's gonna do the same thing. I'm basically gonna see all of our database that we just created before. But obviously we want to do this because we usually have to work with a very big very big data. So we want to do this normally for, like, let's say we have to work with 1000 rows. We want to do this, like, we want to do this manually. We're obviously going to import a file, and we're going to learn how to work with data frames by using a CSV file, import it from this website. So Kaggle, like, if you go here, you can just find anything you want. For example, let's go on IMDb data with movies, and you can find all of the data here, all of the data that you want to work on. And yeah, you can see everything here, like the columns and all of the rows. And this is how you read basically. This is how you basically read the file by using the command read CSV. I imported the file from GitHub because it was much easier. And if I run this command, I'm gonna have the file now. So let's see some basic methods. First, if you just mention the data, we can visualize the whole table by using this command df, which was defined here. And we can see all of the data. It's like a very big table. In many movies, we can see like the columns, rank, title, genre descriptions, directors, and so on. And we can see here that we don't have all of the columns mentioned because there are 1000, and yeah. If we use this command df.head, we're gonna have the first 5 rows of the table, which is considered to be the head of the table. And yeah, we're gonna have the 5 movies. The command tail is gonna give the last, let's say, n rows. Here we're gonna have the last 3 rows of the table. The index is gonna show us how the table is indexed. So basically, the table is gonna be indexed from 0 to 1000. And we're gonna see later what this would mean. The command .describe is gonna give us some statistical data. Firstly, the count variable, and then the mean of each column, the standard deviation of each variable, the minimum. This is I think the quantile percent, the quantile, yeah. This is the median and the maximum as well. So for example, the minimum year is 2006 and the maximum year is 2016. So we're gonna know already that the movies have been released during that period from 2006 to 2016. And yeah, other stuff like the rating, for example, we have the mean rating. The average rating is 6.72. The revenue in millions for each movie, and so on. With the command df.columns, it's basically gonna give the name of all columns and the number of columns. So our columns are rank, title, genre description, director, actors, and so on. And if you are gonna run this command here, you're gonna have the length of the columns. So we know that like there are 12 columns in our database. df.shape would give us the shape of the table, so basically the number of rows and number of columns, which is gonna be 1012. And the size will be basically 1000 times 12. And it's going to show us how many elements the table has in total. And last but not least, the comment df.dtypes is going to give all the types of the elements for each column. So the rank, the year, and the runtime is going to be, they're going to be integers and written on 64 bits. Whereas the rating, which can be like a float number, is going to be a float 64 type. This is a bit different from the normal types, but this is just how the data frames work. And also, you can notice this weird object type for title, genre, description. This is basically a string type, but is mentioned to be object in data frames. Okay, now we're going to talk about indexing, selection, and slicing. And just keep in mind that the index, as we saw before, starts from 0. And we can see here that it starts from 0 and it's going to be from 0 to 1000. We can still change it. We're going to see in a bit how we can change the index. And now how to access all the details of any movie. Well, we have these two functions, log and ilog. So basically, log works with the index, which is numerical in this case, but as I said, we can just change the index to be another column, and we can reassign it. And if I type this command, we're gonna have the information for the first movie of the database. We can even do like this. Let's say the second movie would be like index with 1, and the second one with the third one with 2, and so on. And the command ilog, it works only with the numerical position. They're kind of similar, but there's a big difference here because we can change this to another column. You're gonna see this in a bit. So with ilog, let's say we want the last movie, and the last movie is always gonna be the -1 movie, the index at -1, and it's gonna give us the 1000 movie. You can see it by the rank. If you want the second to last movie, you can do ilog of -2, and so on. And now you can see here that we can't really see the description of a movie because it's very long, and also like the actors, for example. And if you want the full description or the full actors of a movie, we can basically use this command. So we're gonna get the first movie from the database, and we're gonna apply to the description, which is gonna give the description column. And in this way, we can see, and we can get access to certain columns of the data frame. And here, if you want the description of the last movie, we can apply description to ilog of -1. Okay, is there everything clear so far? You can show us like you can give us some thumbs up in the chat. Okay, just gonna continue. And now we're gonna learn how to access one or more columns of the table. So basically what we did here was accessing the description of one movie, but now we can access, for example, the year of all of the movies. And you're gonna see for the first movie, there is 2014, for the second one, 2012, and so on. And how data frame works is basically if we add a list of a column, it's gonna show it to us in this format, which is much more beautiful than the other one. And let's say we want 2 columns, we can just add a year to this add the title to this year list. And now we're gonna have 2 columns for all of the movies. And here, if you're gonna mix these things up, if you want the title, rating, and the year of the 5th movie, for example, we can just add this list to the 5th movie. So the 5th movie is Suicide Squad, and we're gonna have the rating, the year, and the name of it. And what concerns the selection of more movies from the table, you can do this with slicing. So basically, this command is gonna give us the first 3 movies from 0, colon, and then 3. And we're gonna have the first 4 movies. This command is the same as the second one. So basically, I can just not write 0. If I want, I can just write a colon and 3 if I want the first 4 movies. I can even do this for the movies from 1 to 3. Or, sorry, for the movies from 0 to 3. And here I can even I can even play a bit more with these things, and I can show the title for the first 4 movies. Or let's say that, and we're gonna have them here. Or let's say the title and the rating for the first 3 movies. And with a function called ilog, we can even get the first 3 columns of the first 3 movies. It's gonna be something like this: the rank, the title, and the genre of the first 3 movies. And now I'm gonna show you how to change the index of the table. So basically here with this command set index, I'm gonna change the index, which was numerical before, to title, and I'm gonna set the in place to true because this is what is gonna happen to the database. So we want the database to be updated in place. And now if you're gonna print the head of the data frame, you're gonna have here the title as the index, and the title is going to disappear from the main. It's not going to be a column anymore in the database. It's going to be only the index. And if we're going to run this command, we're going to see that the index is the following. So instead of numbers, we're going to have the title of every movie. And here, instead of saying df.log of 0, we're going to say df.log of Guardians of Galaxy. And we can check if any movie is in the table. We're gonna see this. If I wanna get, let's say, if I wanna do the same thing with slicing from here, from here, we can do this with the name of the movies instead, with the titles, because we changed the index. So basically, if you're gonna run this command, we're gonna run all of the movies from Guardians of Galaxy to the sync movie. And we see here all the movies from here up to sync. And now, as we just messed up our database, we have to import the table again. And so the index would be the same as before. And the last thing I'm going to show you before Eric comes and continues is going to be how to use conditional arrays and how to perform conditional selection for a data frame. So basically, let's say we want to know what are the movies released before 2011. And basically, we're going to go to the year column and we're going to perform this thing. And what this what would this show is basically for each movie if it's released before 2011 or not, and we have the Boolean variables false or true. So if you want the name of the movies, for example, or all of the column, all of the row, we have to go basically to this column, and what would this do would be basically showing all of the movies that are released before 2011. And here we can see that there are like 260 in total. And if you want to write the title of the movies, we're gonna do this. I'm gonna add a title column here, as before. So basically, before we saw that we can add like an index here, but instead of the index, we just add the Boolean relation. Now you can see with this command, you can see only the titles that are of the movies that are released before 2011. Okay, now Eric is gonna continue. So I'm gonna stop sharing my screen.
Hi, I'm Eric. Somebody's having an echo. Maybe is that you, Darius?
Yeah.
Okay. So I'm actually gonna do some live coding. So I would like to show you how to use the. Sorry, my screen just froze. So I'm going to introduce you to the service that we're using, which is called Colab, and it's provided by Google. And that's why we said that you would need a Google account to follow along. I'm just going to try to share my screen. 1 second, sorry, this is a bit embarrassing. Okay, so I'm going to post a link to this website in the chat in 1 second. Can you see my screen?
Yes.
Okay, that's great.
Yes.
It's all taking a bit of time. Okay, I hope you can click on the link, and it should take you to this very page. And what I'm going to show you is how to set up your own coding environment so you can follow along if you want to. And for that, you have to click here on File and then New Notebook. If you're not logged into Google, it will prompt you to log yourself into Google. And then you should do that. And after that, you can continue as I will show you now. And essentially, you can start coding right away here. For example, you could do a print statement and say print hello. And then you can click on this small play button at the side, and it will execute your code. And this is essentially what you need to follow along. I'm just going to wait a few minutes until everybody is set up, maybe like 3 minutes. Maybe you could even provide feedback and say that you're done setting up. That would be helpful.
Yeah, I'm done.
Okay, perfect. Just wait a little bit more.
Actually, one second. I'm sorry, one question.
Sure.
So I clicked on the link. What do I do then again?
Oh, sure. You can go to File
Mm-hmm.
and then New Notebook.
Okay. And then did we have to do the first command, or what was the first one? The print.
Oh yeah, you don't have to do it. It's just to show how it will work.
Oh, thank you.
Yeah. Okay, yeah, that's a very good question because we used Replit all the time. The advantage of Colab is that when you look, for example, at the tables that Darius just showed us, they are rendered in a very nice way. They look very good. If you do it on Replit, it's a very it's not a very pretty interface, you could say. So Colab is really very much specified, or specifically, it's made for data analysis. So there are a lot of built-in features that allow you to visualize things more nicely, and that's the main reason why we chose Colab. Okay, I think I'm going to start to continue then. and get actually started. So the first thing we need to do is copy the data frame that Darius just showed us. And just for clarification, you can think of a data frame as just being a table. For example, if you've used Excel before, then it's nothing different than just a table in Excel. It's just called data frame. Okay, so first of all, we have to import pandas, and you can copy and paste the code, or you can just write it out. This is just so we have access to the library, because we obviously need that for everything to function. And then you should probably copy and paste this, because you don't want to write all of that probably. And one thing about how Colab works is you can have different code cells by clicking on this tiny edge below the first code cell and click on plus, and that will create a new cell. And then you can copy and paste this command in there. And then you should run both of these after one another. So you should run this one first and then this one. So you actually have the data frame in here. And what you then can do is you can start really coding, because now we're basically done with the setup, and now we can do interesting stuff. And the first thing that Darius already showed is the head command. Yeah.
So sorry, another question.
Fine.
I wanted to ask, is that information on the other page, like just what Darius?
Oh, sorry. Yeah, I should have said. Yeah, it's on the link that I sent. It's in this chapter. If you scroll down a bit. Mm-hmm. But I can also copy and paste it into the chat. That might be helpful if you don't want to search for it.
Mm-hmm. Thank you.
Hope that works. Okay, and then you can see that this will work like Darius just showed, or hopefully it does. Okay, and then I'm kind of going to continue with a bit more information. So the first thing I'm going to be covering is sorting. So basically, the problem we want to solve is that we want to sort the table by the value of a column. So in this example, if we look in the table, we have a column that's called runtime in minutes, which is just the length of the movie. And let's say we want to find out what the shortest movie is in our table. Then we can go ahead. I'm just going to delete that, and we can look here. We can use the function called sort values, and then we can provide the name of a column. And this is a bit tricky because you have to be very specific about the way it's written. So the best thing I find is just to go ahead and copy from this table here. And this should do it, I think, yeah. And so we can see that the shortest movie is, I'm not going to try to pronounce that, but we can see the shortest movie, and we can, more specifically, we can see that the movies are sorted by the runtime. You can see that it's getting bigger here, and then there are some movies that are not listed, and then we can see the rest of the movies and the longest movie down here. And what we can also do, if you want, we can combine the sorting with the head method we just showed, and we can just add head at the end, which will then make sure that we only see the first 5 movies. That's a bit more neat way to show it. Okay, I'm going to give you a bit of time to maybe try it out on to get it to work on your machine. And if you want, you can go ahead and try out different column names, and for example, sort by the year, or maybe I don't know, sort by the revenue. So you can kind of experiment a bit, and maybe try to find out some stuff about the database. I'm just going to give you maybe like a few minutes to maybe get it to work on your machine.
Sorry, how did the table appear? Because I did include the first code with PD read CSV, but then I didn't get the table.
Yeah, for that you have to write df.head and then click on execute.
Oh, okay, thank you.
Yeah, should have been more clear about that. Sorry about that. Okay, I'm going to continue then, unless somebody has objections. So right now we can only sort by in ascending order. Wait. Oh yeah, this is the sort table. We can only sort in ascending order, but sometimes we would want to sort in the opposite direction. And if we want to do that, we can add an argument to this function, sorry, which is called ascending, which is a bit counterintuitive because we want to do it in descending order now. So what we have to do is set the ascending to false. So it's a bit backwards. But this is the way we do that. And if we click on execute now, we will see that the longest movie is listed first. Okay, and yeah, so one thing to keep in mind is that this doesn't actually change the data frame. If we were to create a new cell and say df.head and execute that, we would see that it's still unsorted here. And why is that? Well, it's because this operation creates a copy of the table, and but doesn't change the original. So we still have the original, and then on the other hand, we have the copy that is actually sorted. If we want to change the original, we would have to go in and add another argument, which is in place, and set that to true. And if we execute this, sorry, you can't call the head on that then, which is something technical I won't explain now, but if we call this and then we call the df.head, then we can actually see that the sorting did get incorporated into the actual data, into the actual data frame, into the actual table that we're working on. Which is a bit of a confusing distinction maybe, but if there are any questions about that, I'm happy to try to explain that. Otherwise, I'm going to move on into how to insert columns. I'm going to, I don't need that right now. So if we just want to make a copy of a column, for example, we can just go ahead and select the column in question by using the syntax we already, Darius already showed, which is just the data frame and then in brackets the title, or rather the name of the column, which in this case we want to create a copy of the title, and we can basically do this by assigning this the title row, title column to a column, and then we can pick a name, for example, title copy. And I'm just going to add the df.head again. What this does is it shows the changes. And we can see that here at the end there's a title copy, which it's not very useful, but this is how you can create new columns. So now let's try to actually do something more useful with inserting columns. As you can see here, what the image database actually has is the one thing is the rating, and then has a metascore. These are both ratings for the movie, but they're from different sources. So I thought it would be interesting to actually compare those two ratings against each other, to see if they have the same opinion on the same movie, or if there's a big difference in opinion between those two ratings. And for that, we can also create a new column. Let's call it maybe rating difference. And what I want to show you is that you can actually do calculations on the columns themselves. So let's pick the rating. And if we look at the data here, we see that it's roughly between 0 and 10, whereas the Metascore is between 0 and 100. So the Metascore is given in percentage. So what we would want to do is convert both of the, or rather we want to convert the rating to be in percentage, so we can compare the two. So for that, we have to multiply by 10, because to get from 0 to 10 to percentage, we would have to multiply by 10. And then to get the difference, we want to subtract the Metascore. And then we want to print out the result again. Okay, and as you can see here, you can see the rating difference. And if you look into here, we see that the rating is 7.8. So if we would convert it to percentage, that would be 78. And the Metascore is 68. And the difference between those two would obviously be 10. So we see that the calculation did get right. One thing you might have noticed is this NaN here, which stands for not a number. And this happens when there is some sort of missing data. And here in this example, you see that the Metascore is not a number, so it's missing. So that's why we can't do the calculation on the rating difference, because we don't have the one data point. Just something to keep in mind, I guess. Okay, now I'm going to show you how to delete columns, because maybe this title copy column, we noticed we don't actually need the title copy. So we can go ahead and use the df.drop method. And this just takes in the name of the column. And then we have to specify a so-called, oops, this has to be comma, sorry. We have to specify a so-called axis. And essentially what the axis is kind of the direction you look at the direction from which you look at the table. So if you specify axis equals 0, you're looking at it from above. So you're basically considering the columns. And this means that we want to delete a column. And let's try that out. This is a bit embarrassing now. Sorry, it's the other way around. You have to specify 1. Yeah, I got that wrong. And now you should see that there is no title copy anymore if you compare those two. As I've already hinted at, if you want to delete a value, you can do that in a very similar way. So for example, if you would want to delete the first value, we would specify it like this. I'm not sure if it's 1 or 0. I need to try. Yeah. So I'm not sure if you can. Okay, so what I'm going to do is I'm going to run this cell again so we can restore the data frame to its original state. And then we can first of all, let's see how it looks. Okay, so we see that Guardians of the Galaxy is the first element in the list. And if we go ahead and use the drop on the 0th element, then we can see that the second element here has taken the place of the first row. So we see that it got deleted successfully. Okay, yeah, and that's all I want to show you about deleting things. And now, when we've done some changes, so let's for example order the database again. We can actually go ahead and save our database, or rather our table. Sorry. And for that, we can either use the command df.to_csv, and this will just store it as a CSV file, which is comma separated values, just so that we're on the same page. And then you should be able to look here and see that the test CSV, this is the name that we specified here. We can see that this actually got saved. And we can indeed verify that we have successfully ordered the runtime, the movies by the runtime here, as you can see. Okay, what you can also do is you can, instead of saying to CSV, you can go ahead and say to Excel, which, as the name suggests, stores the table as an Excel file. And let's see if that works. We need to click the refresh button here, and it indeed does show up as an XLSX file, which is perfect to edit in Excel if you want to continue editing it there. Okay, we're running a bit short on time, so I'm going to skip an advanced topic. But if you want, you can. Oh, oops. So this is the last topic I wanted to cover, but we can skip it very well because I kind of planned it like that, so we don't actually have to do it. But if you want, you can take a look at it on your own. And finally, I have added some sort of practice. Oops. Some practice exercises, I guess you could call them, that you can do if you want to. And I'm actually going to try to do the first one. Exactly. So what are the 5 best movies released in the year 2014? So for this, I'm going to jump back into the live coding environment here. And so we want to figure out the best 5 movies released in the year 2014. So first of all, we have to find the movies that have been released in 2014. So we have to look at the year. And this goes back to what Darius showed you about selecting certain rows. Not sure where it was. Doesn't really matter, I suppose. So we would want that to be equal to 2014. Let's just run this to verify if that gives us the correct result. And indeed, we can see that all of the movies that have been selected here are from the year 2014. And so the next stipulation is that we want to find the best movie releases, which I guess we would have 2 options. We could go by the rating or by the Metascore. I think we should go by the Metascore maybe. So what we want to do is on this subset of the table, we want to sort this subset, and we want to sort it by the Metascore. Recall this is the same thing we did here, but now we're just combining the 2 operations. And in this case, we want it to be descending, so we would have to set ascending to false. Oops. And because we only want the first 5 values, we can call the head function. I think I did a spelling mistake. Yes, this looks good. Yes, and then we can see we have the best movies from 2014, which we can see the Metascore is very high, and it's ordered by the Metascore. Okay, this is basically everything I wanted to show you. If you want, I'm not sure, we're running a bit low on time, so maybe I'm going to show you the preview for next event. It's a bit of a teaser for what we want to do in the next event, which is plotting stock data. And I added this small preview here. You don't have to worry about the output here, but this is what we're going to do next time, and it's just a quick preview. This is the stock from Apple, and we will show you how to basically work with real-time or live stock data, and how to, for example, create plots of the stock data. Okay. Yeah, and if you want, please feel free to join our Discord. It's linked here in the document, so you should still have the document, I hope. And I also added some useful resources for learning Python and pandas in specific. One thing I want to highlight is this free online book for Python beginners, which is really cool. because it actually, you can read it here online. It's all of the book. And it's really cool because it's for Python beginners. And it's very practical because it shows you how to, like it says, automate the boring stuff. It shows you how to automate certain tasks that you might have in your day-to-day life, or if you have a job, you might have in your job. So this is something that's really worth checking out if you want a practical introduction to Python. Yeah, and I think that's it on my end. Feel free to look at the practice exercise if you want to spend some more time on Python. And there are also solutions for all of the exercises. And please, if there are any questions, please feel free to go ahead.
I just wanted to say thank you so much, Darius and Eric. It was really informative. Also great to have that file so that like we can go over the things as well. I'm going to stop the recording now. 1 second.